Water mass m equals to 20 gram is enclosed in a thermally insulated cylinder at a temperature of 0 degrees Celsius under a weightless piston whose area is S equals to 1410 centimeters square. The outside pressure is equal to a standard atmospheric pressure. To what height will the piston rise when the water absorbs Q equals 20 kilojoule of heat? From the question given, heat transfer dq equals to Q equals 20 kilojoule, mass of water m equals to 20 gram. Let the piston is pushed up by the vapor against constant pressure, standard atmospheric pressure P0, till the mass m1 of water is converted into vapor. Now work done will be dW equals to integration P dV equals to P0 dV equals to P0 into S into H, where H is the height through which piston moves up. Now from first law of thermodynamics, dQ equals to dE plus dW. This by Q equals to mCV dt plus P0 into S into H plus M1 into Q. Also from ideal gas equation, we have PV equals to N into R into T equals to M by M into R into T. This implies P0 into S into H equals to M by M into R into T, where T is the boiling point of water at pressure P0. Hence M1 equals to P0 into S into H into M by RT. Hence from equation 1, we have Q equals to M into CV delta T plus P0 SHM by RT into Q plus P0 S into H. This implies H into under bracket P0 into S into M into Q by R into T plus P0 into S equals to Q minus M CV into delta T. Hence H equals to Q minus M into CV into delta T by P0 into S into under bracket MQ by R into T plus 1. Putting all the values given in question, we get H equals to 20 cm. One gram of saturated water vapor is enclosed in a thermally insulated cylinder under a weightless piston. The outside pressure being standard M equals to 1.0 gram of water is introduced into the cylinder at a temperature T0 equals to 22 degrees Celsius. Neglecting the heat capacity of the cylinder and friction of the piston against the cylinder's walls, find the work performed by the force of the atmospheric pressure during the lowering of the piston. Since when the saturated vapor pressure is enclosed in a thermally insulated cylinder, the outside pressure is a standard P0. Hence, the inside pressure should also be standard. Hence, the temperature will be at saturated pressure for water T equals to 100 degrees Celsius. If the water at temperature T equals to 22 degrees Celsius is inserted into the vessel, the temperature of the mixture reduced and hence there is some condensation of saturated vapor. Using the concept of latent heat, that is Q equals to M into Q, and ideal gas equation, we can find work done A equals to M into C under bracket T minus T naught into R into T by Q by M equal to 25 joule. Answer. Question: if an additional pressure delta P of a saturated vapor over a convex spherical surface of liquid is considerably less than the vapor pressure over plane surface, then delta P equals to under bracket rho V by rho L into 2 into alpha by R, where rho V and rho L are the densities of the vapor and liquid. Alpha is the surface tension. Using this formula, find the diameter of water droplets at which the saturated vapor pressure exceeds the vapor pressure over the plane surface by eta equals to 1.0% at a temperature T equals to 20 7 degrees Celsius. The vapor is assumed to be an ideal gas. Since the pressure of the convex surface is less than that of the plane surface and given by delta P equals to under bracket rho v by rho L into 2 alpha by R, where rho v equals to density of vapor, rho L density of liquid, alpha surface tension, and R equals to radius of curvature. Now for vapor we can use ideal gas equation, assuming vapor to be ideal PV equals to nRT, or PV equals to m by m into R into T, or P equals to under bracket m by v into RT by m. This implies P equals to rho v into RT by m. We know that the water will take the same shape and size as that of the convex surface. That is, the diagram of convex will be equal to that of water droplet. Hence delta P equals to under bracket rho v by rho L into 2 alpha by 2 R into 2 equals to rho v by rho L into 4 alpha by d, equation 2. Hence from equation 1 rho v equals to Pm by RT, and also from 2 delta P equals to under bracket rho v by rho L into 4 alpha by d. This implies Pm by RT into rho L into 4 alpha by d. This implies delta P by P equals to m by rho L into R into T into 4 alpha by d. This implies eta equals to m by rho L into R into T dot 4 alpha by d. Hence d equals to 4 into alpha into m by eta into rho L into R into T. Putting all the values, we get the result d equals to 0.2 micrometer. Answer.